Sometimes it feels like math has its own secret language, right? Like one wrong step and suddenly you get a totally different answer. Well, today we are going to crack that code. We're going to demystify the basic rules of math so that all that confusion turns into clarity.
Take a look at this. It probably looks a little intimidating. So many numbers, so many different operations. Where would you even start? I promise you, though, by the end of this quick explainer, you'll know exactly how to tackle this with total confidence. So here's our game plan. We're going to start with the absolute basics, the building blocks. From there, we'll get into basic and then advanced operations. Then we'll cover the ultimate rulebook that pulls it all together. And finally, we'll talk about why any of this actually matters in the real world.
All right, first up, the building blocks. See, before we can actually do anything, we have to understand the materials we're working with. And in math, our materials are the numbers themselves. Getting a handle on these is step number one.
I like to think of it like this. Math is a lot like building a wall. You just can't build something strong and reliable without understanding your individual bricks first. And for us, those bricks are the different kinds of numbers we use every single day.
So our first type of brick is the whole number. These are the simple, clean counting numbers we all learn as kids. 0, 1, 2, 3, and so on. Nice and easy.
But what about things like debt or temperatures below freezing? Well, for that, we need to expand our toolkit to include integers. Integers are simply all the whole numbers plus their negative opposites. So you've got your positive numbers, your negative numbers, and good old zero sitting right there in the middle.
Okay, so we have our number bricks. Now, let's learn the most basic ways to start putting them together. It's time to talk about the rules for adding and subtracting.
The easiest way to picture this is to imagine a number line. Adding a positive number, you move to the right. Adding a negative number, or subtracting a positive one, you move to the left. But here's the one that trips people up. Subtracting a negative number actually moves you to the right. It's like taking away a debt. It's a good thing.
So keeping that number line in your head, let's try a quick one. If you're starting way down at negative 35 and you add 19, which direction are you moving and where do you think you'll land?
You land on negative 16, because you started at negative 35 and you moved 19 spots to the right, getting closer to zero. See? It's really just about movement.
Now we can build on that and get into our next section, multiplying and dividing. And seriously, don't let that word advance trick you. The rules here are actually even simpler.
This little table says it all, but here's the only thing you really need to remember. When you multiply or divide, if the signs are the same, so 2 positives or 2 negatives, your answer is always positive. If the signs are different, 1 positive and 1 negative, your answer is always negative. That's it. That is the entire rule.
Okay, let's test that rule out. What do you think happens when you multiply a negative 14 by a positive 65? Just think about the signs. Are they the same or are they different?
The answer is negative 910, because a negative times a positive gives you a negative. Simple as that. And once you know that rule, you can apply it to any numbers, no matter how big or small.
All right, we've got our numbers, we've got our operations. Now it's time for the main event. This is the single most important rule that ties everything together and lets us solve those complex, multi-step problems. Welcome to BODMAS. BODMAS is basically an instruction manual that gives us the exact order to follow. First, you solve anything inside brackets. Then you handle any orders, which means things like exponents or square roots. Now, this next part is crucial. Division and multiplication are partners. You solve them as they appear, working from left to right. Finally, addition and subtraction are also partners, and you solve them from left to right too. This isn't just a suggestion, it's the universal grammar of math that makes sure we all get the same answer.
Okay, let's go back to that problem from the beginning and use our new superpower. The B in BODMAS tells us to start with brackets, so we have to solve the stuff in the innermost brackets first. That's 5 plus 1.
Right, that gives us 6. Now our problem looks like this. We're still working inside the main brackets, and we've got subtraction and multiplication. Well, BODMAS says M comes before S, so we absolutely have to do 2 times 6 next.
And that gives us 12. Look at that, it's getting simpler with every step. Now we can finally finish what's inside the brackets, 18 minus 12.
Perfect, that leaves us with 6. The brackets are finally done. Now, looking at what's left, our rules tell us that division comes way before addition, so our very next move has to be 6 divided by 3.
Which gives us 2.
And just like that, we've taken that messy, complicated expression and boiled it all the way down to one last simple calculation: 2 plus 7.
And the answer is 9. See? By just following that one simple order, BODMAS, we took a problem that looked confusing and solved it one clear, logical step at a time. That right there is the power of having a system.
So we've covered numbers, operations, and the all-important order of operations. But so what? Why does any of this matter once you're out of a math class? Let's wrap things up with the big picture.
Because here's the thing. Math isn't really just about numbers. It's a language. It's a way to train your brain to think logically and solve problems in a systematic way. I mean, whether you're following a recipe, building furniture from a manual, or planning a big project, you are using an order of operations. So think about it. Where in your own life do you use this kind of step-by-step logic, maybe without even realizing it?